Hello, Spreadsheet Nation. My name is Nate Larmond, and what if you missed the lesson on how to build a spreadsheet when we did the experiment, how does height affect walking pace? So it's pretty simple. Um, a table's just a bunch of column and rows. You can call it a matrix, but it shows different combinations. So we kept track of subject and how each subject had a different height, a different distance they walked, and a different time it took them to walk that distance. So like I said, it's just like a multiplication table you were introduced to in third or fourth grade. You can call it a matrix if you want to sound smart, but I like to organize tables in columns. It makes it easier to draw the graph. Anyway, here's the magic. All formulas start with equals. Speed is obviously distance divided by time, so you could type in 10 and then divide by 7.8, but you click on 10 and something crazy happens. A cell location appears in your formula. C is the column, 5 is the row. That's like where this information is. The cell address is C5. And divide is the little slash, and you click on the time. So you know the equation, speed equals distance over time, but it looks weird in a spreadsheet. Equals C5 divided by D5. Again, this is just called a cell location, so D is the column and 5 is the row. Notice the cool color coding. This is yellowish, showing you to this yellowish cell, and here's the purple in the formula, and here's the purple cell. So you hit enter, and you're like, great, that didn't save me any time at all. I could have just click the buttons on my calculator, right? Yeah, except if you mouse over the lower right of this cell, your cursor changes into a black cross. Hold that and drag it down. That's called the autofill handle. So you just saved yourself like 5 minutes on the calculator. That's what spreadsheets are all about. Significant figures describes the uncertainty in the measurements. We have a kind of wide range of significant figures in the distance column here. This is 1, this is 2, this is 2. 3.05 is also 3 significant figures. Again, a wide variety in the time. We have 3, 1, 3, 1, 3 significant figures, and finally 2 significant figures. So it's actually totally unclear how we should round this. To round in a spreadsheet, you highlight it and you hit this little 0 with the arrows, and I'm chopping decimal places. Maybe 2 significant figures is cool. Okay, so the table's done. I mean, we could pretty it up a little bit if you want to. Yeah, you could center this. You could put a little border around it. We could pull this to the left and then merge and center the title. This is all sort of formatting stuff. Whoops, where's merge and center? Here's merge, and then you center it. Okay, so I'm not that worried about that. What I want is to see if there's a relationship, a mathematical pattern in between height and walking pace. That's the objective of the experiment. So you highlight the independent variable data, that is from 72 down to 64, hold control, CTRL, and then highlight the dependent data. This is the Y data. So it's just like an order pair. X is on the left, Y is on the right. Hit insert, hit chart, and whoops, let me move my screen. Google Sheets loves column charts for unclear reasons. The 2 variables are clearly quantitative, so it should have chosen scatterplot, but that's okay. We can choose scatterplot. Sorry, I keep moving my screen here. Everything is cool. We don't need to mess with setup. It chose the right cell locations from B5 to B11, and then the next set is from E5 to E11. We do need to add some things to this chart though. So go to Customize, this right-hand tab, and then hit Chart and Axis Titles. And then, let's see, it's walking pace as a function of height. You can always say Y is a function of X. That's sort of a standard way of describing a mathematical relationship. And height, we measured in inches because we're Americans. And the vertical axis is walking pace. At least we went metric for the distance and time we moved. So this is meters per second. Okay, so we have a title for the graph. We have label on the X, label on the Y. Still, I would say this graph is a few steps short. So let's minimize chart and axes title. Let's expand series and scroll down, and bang, right there. Hit that trend line box. Looks like a pretty gentle slope until you fix the scale. Oh, hang on. I actually like the formula for the trend line. So hit label, change it from none to use equation, and then it shows up at the top. This is y equals mx plus b. So there's the slope. How many meters per second change is there for every 1 inch change in height? That's the meaning of the slope. Here's the meaning of the intercept. It's the y-intercept, so it's meaningless. Let me actually zoom out. That's what I wanted to do. I'm going to change this x-axis scale, and I think the truth will be more obvious. That is, we're trying to figure out how these two variables relate to each other. And when you're zoomed in like this, it's really not clear how they relate to each other because we're only looking at a really tiny range in the independent variable from 64 inches tall to 72 inches tall. And that was the main problem in our methodology. Everybody was basically full grown. So we're going to change the minimum. Sorry, what I did was I went down to horizontal axis, expanded that menu, and then hit the minimum to be 0. Okay, so like I said, the y-intercept is kind of meaningless. It's down here. The x-intercept has a lot of meaning. So I don't know, what are we looking at? 51, 52, something like that. This predicts that above 52 inches of height, you're going to walk faster, faster, faster. And shorter than 52 inches, you will have no walking pace, like it's undefined. I don't know what a backwards negative walking pace means. So this x-intercept actually predicts the height at which you can start walking. It's wrong, of course. Kids start walking when they're about 1 year old, so it should be, I think, closer to, I don't know, 30 inches, somewhere around here. So what went wrong? Well, like I said, our methodology was wrong. Our sample size was too small, and more importantly, the range in our independent variable was too small. We needed some little kids, we needed some medium kids, and like you guys, we have some big kids. So, like I said, if you missed the lab and how we drew this graph, how we put the formula in the spreadsheet, there you go. You're caught up. Thanks for watching. See you in the next video.